3.1 and 3.2 notes. We're going to be talking about finding the slope from 2 points as well as graphing equations from slope-intercept form and graphing them on a line. So we'll be doing that so that we are able to represent linear functions on a graph. And you can do it when you're able to find the slope from 2 points and graph from slope-intercept form, be able to graph a line. Okay, so what is slope? Slope is the rate of change from one point to another. And in linear functions, the rate of change between 2 points is always the same. So just like we kind of talked about with arithmetic sequences when we were looking for the common difference, that common difference was the same between numbers every time. The slope is similar. It's the same change every time. And when we're talking about between 2 points, we describe the slope as rise over run. So the rise describes the vertical change and run describes the horizontal change. So when we're finding the slope from 2 points, when working with points, we can subtract the values from one point to the other to find the rate of change between the rise and the run. And so I've written down 2 different kind of formulas. Now they're not very different, but there are some differences. And the first is the one that I grew up using and probably many math people, which is y2 minus y1 divided by x2 minus x1. And if you notice here, our 2's are stacked and our 1's are stacked. So we do our second term minus our first y term and our second x term minus our first x term. Or we can do it the other way. We can say our first y term minus our second y term divided by our first x term minus our second x term. So it really doesn't matter which order you write them in. What matters is that the orders correspond. So if you're going to use your second term for your y first, then use your second term for your x first. You can't mix and match and put y2 and x1 and all that kinds of stuff. These have to line up. So as long as those are lining up, you're okay. So we're going to practice these. I'll do a couple with the first formula and a couple with the second formula. So the way I like to do these, I like to label these. So here we have 2 ordered pairs. These would be points on a graph, and this is our x coordinate and our y coordinate for our first point. So I'm going to call that x1 and y1. And this is my x coordinate and y coordinate for my second point. So I'm going to call those x2 and y2. Now, based on our formula, y2 minus y1, I'm going to take my y2 value minus my y1 value. So in purple here, I'm saying y2, which was 18, minus my y1 value, which is negative 14. And that's divided by my, I'll do this in blue, my x2 value, which would be 20, minus my x1 value, which is 5. So y2 minus y1 over x2 minus x1. And then what I'm doing is if I have double signs on the inside like I have here, I can slash and dash, or you can just think of it as this is saying the opposite of a negative 14, which means it's a positive 14. Probably going to be cleaner for me to just rewrite that, but I grew up doing I turned my double negatives into a plus. However, you see fit to do that. Okay, slash and dash. The signs on this tend to be the most difficult part, that and if kids or students write them in the wrong order or mix up their order. So 18 plus 14, so I'm going to do 4 and 8 and get 32. So 18 plus 14, 32 over 20 minus 5. Nothing too fancy going on there, and that's 15. And 32 over 15 is not going to reduce. So my slope is 32 over 15. Okay, again, same idea. I'm going to call this x1, y1, x2, y2. Now I'm going to do the other direction. So I'm going to put my y's still always go on top. So I'm going to do y1 first. So 15 minus my y2, which is negative 19. Notice how part of our formula is including this minus sign, and then whatever the term is that we're putting in the formula also has its sign attached to it. That's how we end up with some of those double negatives. So 15 minus negative 19. I also have negative 4 minus 7. So as we calculate these, I have double negatives turn into a positive. So I'm going to do 15 plus 19 on top. So we're doing 15 plus 19 on top to get 34. And I'm doing a negative 4 and a negative 7. Signs are the same, so we add them and keep the sign. And we are going to get negative 11. These will not reduce, so my slope is, and I'm going to write this negative. We usually don't write it in the denominator. We're going to write it either off to the side or with the 34. So negative 34 over 11. All right. I'm going to do these last two very quickly. Taking my y2 minus my y1 divided by my x2 minus my x1. And notice that I do end up with a double negative, becomes a positive, slash and dash. 10 minus 8 is 2, and 4 plus 6 is 10. These ones reduce to give me 1 over 5, so my slope is 1 over 5, rise over run. All right, and then finally I have x1, y1, x2, y2, and this one I'll do my x1s first, or my ones first. So y1, so negative 14 minus, and notice, like, you really could, just in setting this up, here's what I'm doing. I'm putting a term here minus a term here, and my term here minus my term here. So I have my y and y, x and x. I'm doing y1, negative 14, minus my y2 and negative 6. And then down below, I'm doing negative 12 minus x2, which is 8. Some funny sign things going on here. These double negatives make it a plus, so I really have negative 14 plus 6. This is negative 12 minus 8. And that ends up giving us a negative 8 on top and a negative 20 on the bottom. And then we can reduce, so our signs, I have the same sign, so it's actually going to end up being positive. And 8 over 20, 4 goes into 8 twice, and 4 goes into 20 5 times. So our slope is positive 2 over 5. So that's how we would find it if we're given 2 points. We use our slope formula. If we're given a line on a graph, we are going to pick 2 points on the graph. So we have to make sure that they're actual points. Some of them may look close and they're not actually points. And then we just count the rise and the run from one point to the next. Usually we move from the leftmost point to the rightmost point. So for this first example, as I'm looking here along this line, you can pick any 2 points. Now, I prefer to try and pick, for example, in red, if I pick a point here, I could very well pick a point down here or here, whatever I see. If you notice where our lines cross, there are several points along this line. Your best, or the kind of simplest way to do it, is to do the 2 consecutive points. But if you don't see it, you just end up having to reduce a fraction later on. So I'm going to count, let's see, I'm going to delete these. And I'm going to count my rise. So my rise to get, if I'm only allowed to walk along the lines. Let's be silly here. Let's just go for it. There I am. And I'm hanging out on this point here, and I need to get to my next point, but I can't follow this line to get there. I can only walk along my lines. So I'm going to walk down 2. So I'm going to go boop, 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 boop. And now I can go right 1. So that's how I'm counting my slope. My rise was -2 because my person had to move down. My run was +1. So for this example, m equals, m is interchangeable with slope. I don't think I've covered that yet. But when I say slope, I can also refer to it as m. That is the letter that we use that kind of stands for slope. And we'll be using that more in a second. I went down 2, and then I went right 1. So I went 2/1. Take another quick look over here. I'm looking for clear, concise points. I for sure have one here. That's great. My problem is this is close, but it's not actually crossing. This is close, but it's not actually crossing. And what I would notice is my next actual point is all the way down here where it's crossing. Okay, so let's get Mr. Graves back over here. And from my leftmost point, I'm counting my rise, which I'm going up 1, 2, 3, 4, 5, 6, 7 lines. So up 7 is my rise, so +7, and 1, 2 is my run. So I'm saying my slope is 7/2, and that's how we count that out. All right, moving along. Undefined and no slope. So if we have vertical lines, so if you are given a graph, and on your graph you have a vertical line like this, this would be an undefined slope. Horizontal lines, if you think about skiing and a ski slope, a horizontal line will have a slope of 0 or no slope. So again, if we had a graph here, a slope of 0 would be a horizontal line. There's no slope there. So if you like going snowboarding like I do, I for sure don't like snowboarding down undefined lines because it's undefined whether or not I'm going to break a bone. But I also don't like snowboarding on 0 slope because it's flat. There's no slope whatsoever. We also run into that when we're following our y2 minus y1 over x2 minus x1. So as I label these, I'm going to do y2 minus y1 over x2 minus x1. And when I work that out, that's plus. That's going to give me 13 over 19 minus 9 is 0. If I have 13 divided by 0, if you try and punch that in a calculator, you create a black hole in the void, and thanks for making 2020 more difficult. This is undefined. There's no, you will get error in your calculator. You cannot divide 13 by 0. This is undefined. However, my next example, x1, y1, x2, y2. I'm going to do my y2 minus my y1 over my x2 minus my x1. Get that double negative in there, that becomes plus. On top, 3 minus 3 is 0. On the bottom, 16 minus 11 is 5. 0 divided by 5, if you do that in your calculator, you just end up with 0. So this is no slope. This is a slope of 0 versus undefined. Okay? Let's talk about graphing. This is not going to take us very long, hopefully. There are two kind of forms that we're going to be working a lot with. Today's lesson, we're not really going to talk about point-slope form, but I did want to point out that it is a thing. And usually, if you're given a point and the slope, you would use point-slope form to be able to graph the equation. Slope-intercept form, y equals mx plus b, is what we are going to be camping in on today. And earlier, I pointed out that m, it means the same thing as the slope. So that's my slope. And b, which I'm going to highlight in blue here, b is what we would call in slope-intercept form, this is our y-intercept. And that means that's where the line crosses the y-intercept. Pardon me. So we have our slope and we have our y-intercept. And we use that information to graph. So you may see something like, I don't know, y equals 2x plus 4. In this case, our slope, or our m, is 2, and our y-intercept is 4. If we saw something like y equals negative x plus, or we can say minus 6, our slope is the value next to x. It's the value that's multiplying with x. In this case, it's a negative 1. And our y-intercept is a negative 6. So we leave the signs attached. Okay. So when we're graphing, here are some nice steps that I've written down. We're going to make sure that the equation is in fact written in slope-intercept form first. If it's not in slope-intercept form, the following steps don't do us any good. Then we are going to identify the m and b values. Just like I showed you up here, they're very easy to identify. Your m is your value that's next to the x. Your b is the value that's at the end. If you don't see an m, it's a 1. But if you don't see a b, it's a 0 because it's not there. So if we don't see an m, like this would be the most simple example, y equals x. We do have an m. In purple, we have an m of 1, because that is 1x. However, in blue here, we don't have a b. I can't just tack a plus 1 on there. That would change that. So really what's there is a 0. So if we don't have a b, it's 0. If we don't have an m, it's 1. So we identify our m and our b's. I like to write them down. Then I'm going to draw arrows for my rise and run. Positive rises up, negative rises down, and I'm always going to try and run right. I'm always going to run right. Then I'm going to begin by plotting b on the y-axis. I will move, so m and b, b stands for begin. That's where you start. You begin on the y-axis. M is how you move from that point. So we're going to move by counting rise and run, and then repeat that as necessary. Here's the thing. With this rule here, with rule number 3, it works as long as we apply this. If you cannot move because there is not enough graph, you move the exact opposite. And then we would go like, if we can't go down and right, we would go up and left. If we can't go up and right, we would go down and left. So, and then finally, step 6, draw a line through the points. This is actually far easier than you would think. If you can identify some information, and plot points and count, you can graph slope-intercept. So let's see here. In example A, we have m equals 2. And in order to make that rise over run, I've got to make it a fraction. So I'm going to turn this into 2 over 1. And I'm going to draw some arrows here. It's positive, so it's going to go up, and I always go right. My b value is 1. So I'm going to begin at 1, and then I'm moving up to. So my b value is 1, and then I'm going to move from that point up to right 1. So let's plot this. I begin at 1, and I always begin on my y-axis, up and down. I'm not going to begin here. I'm not going to begin on my x-axis. I'm just going to make a big scribbly mess because that's wrong. I begin at positive 1, and then again, here's Mr. Graves coming in with a little stick figure. His head's broken, his neck's broken. It's like hanging off the side there. He just has bad posture. Okay, I'm beginning at 1, and then I'm moving up to right 1. And I will put a point there. And then I can move up to right 1. Put a point there. Up to right 1. So again, I move up 1, 2, right 1, put a point. 1, 2, right 1, put a point. 1, 2, right 1, put a point. And the lines are kind of hard to do on the iPad, so just so you're aware. All right, so check it out. There's my line. Remember what I said about doing the exact opposite. The exact opposite of up to right 1 would be down to left 1. Watch what happens in red here. If I were to go down to left 1, I still land on the same line. So that's why we can do the exact opposite. And that's it. We've graphed our line. We do like putting arrows on our lines because should the graph be larger, it would extend forever. Okay, so I'm going to not explain this one quite as much. I'm looking for my m value, which is -1 over 3. My negative always goes with my top number, which means instead of rising up 1, we're going to rise down 1. And then I'm always going to the right 3. B equals positive 3. I got that from here. So I begin at 3, and I move down 1, right 3, put a point. Down 1, right 3, put a point. And I've run out of graph. I could also do the exact opposite and go up 1, left 3, even though I went past it. Up 1, left 3, and put a point, and then I can just connect my dots. That's it. So graphing's not that bad. Just a few more examples here. M equals -4. I'm going to put that over 1. That means we're going down and right. B equals 6. So I'm going to begin at 6. And then I move down 4. 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. It's much easier with a ruler and on paper than it is on the iPad, but there's my line. So the problem is if we hit something like this, remember step 1 was to make sure it was in y-intercept or in slope-intercept form. So this one is not in slope-intercept form because y is not by itself. So I can't figure out what my m and b is yet. I don't know how, I'm probably not going to have you practice these in class, but I want you to see them so that you're familiar. So we need to get y by itself. So we need to get y by itself here, which means I'm going to move my 3x and my -2. I'm going to subtract 3x first so that -2y equals -3x plus 4. I could not put these together because they do not have like terms. My next step is I'm going to divide everything by -2. That leaves me with y equals 3 over 2x minus 2. And now that is in slope-intercept form. So my m equals 3 over 2. My b equals -2. Once we have slope-intercept form, it's really fast. -2, and then I'm counting up 3, right 2. And making my line. Okay, 2 more things to point out. Couldn't get them on the same page here. If you are given just a value like this one, y equals 4, and there's no slope or y-intercept here. This is just y equals 4. Great. Here's what I do. I find my y-axis, I find 4, and then I cut through where y equals 4. That's it. So that's going to give me a horizontal line through there, y equals 4. If I had, I'll do another color, blue here. If I had y equals -2, I would find -2 on the y-axis and then cut through it. And it doesn't make sense. It wouldn't make sense to cut through it, the y-axis vertically. There's already a big dark line there. I'll do one more example in orange. If I had y equals -6, then I'm going to find -6 on the y. I'm going to draw a line through it, put arrows. That's not exactly on -6, but you get the point. Same thing works here for x. So if I have x equals -2, here's my x-axis. It goes left and right here. I'm going to find -2 on my x-axis, and then I'm going to cut it right down. Ooh, I don't know what happened there. That was fancy though. And that's it. Do another color. If I had x equals 4, I'd find 4 on the x-axis and then cut right through it. And really what this is saying is it doesn't matter what value of y is, what the value of y is, x is always going to be 4. So if y is 1, guess what? X is still 4. If y is 4, x is still 4. If y is 6, x is still 6. In the same way, if I'm looking for y to be -4, x for my purple line is still -2. X is always -2. It doesn't change. Versus these ones where it's like, okay, well, if x is 2, then y is 1. But if x is 4, then y is 4. 1, 2, 3. Yeah, I did count that right. So these ones are a little bit different, but your vertical ones, y is always going to be 4, so it just cuts across like that.